So this is the most amount of marks I have seen for an exam question involving proof. Altogether, this is worth 8 marks. So if you want to have a go at the question yourself, pause the video and I'll go for the answer now. Okay, so for the first part, we're told that Caden claims that 3x is bigger than or equal to 2x, and we need to determine whether Caden's claim is always true, sometimes true, or never true, justifying our answer for 2 marks. So there are 3 possibilities here. It's either always true, sometimes true, or never true. Hopefully it's quite obvious that it's not never true, because we have this 3x is bigger than or equal to 2x. If x takes any positive value, so for example, if x is equal to 2, so this will be 3 to the power of 2 is bigger than or equal to 2 to the power of 2. 3 to the power of 2 is 9 and 2 to the power of 2 is 4, and this here is true because 9 is bigger than 4. Okay, so it's true for x is equal to 2. So now we need to see whether it's always true or sometimes true, and the answer is it's sometimes true. The reason for this is if x takes negative values, so for example if x is equal to minus 2, this here will become 3 to the power of minus 2 is bigger than or equal to 2 to the power of minus 2. 3 to the power of minus 2 is 1 over 9, and 2 to the power of minus 2 is 1 over 4. And this here is false. 1 over 9 is smaller than 1 over 4, so this here is incorrect. So therefore the answer is sometimes true, and we have proved it by subbing in x values. Okay, and then for the second part of this question, we need to prove that root 3 is an irrational number for 6 marks. Now, we talked about an example like this in the proof by contradiction video. We talked about where we need to prove that root 2 is an irrational number, and this is actually also mentioned in the specification as an example that you need to know, where you need to prove by contradiction that root 2 is an irrational number. Now, here we have root 3, but the method is the exact same. It works the exact same for root 2 and root 3. So remember how to prove by contradiction. So if we're trying to prove that root 3 is an irrational number, the first thing that we need to do for proof by contradiction, we need to assume the opposite. So we're going to assume here, as we're trying to prove that root 3 is an irrational number, let's assume that root 3 is a rational number instead. So remember what a rational number is. A rational number, so root 3 here, a rational number can be written as a over b, where a and b are integers. This is the definition of a rational number. Now, there's one other important thing that we need to say here, where a and b are integers and they have no common factors. The reason that we need to say this is we need to say that this fraction here, a over b, is in its simplest form. So for example, it can't be something like 6 over 4, because these two have a common factor of 2, so this could be simplified down to 3 over 2. So while we're saying that this has no common factors, this means that it's not like 6 over 4 here, it's in its simplest format, for example like 3 over 2. Whatever this fraction is, it's in its simplest format, where a and b are not divisible by each other. Okay, so we know that root 3 is equal to a over b. If we square both sides here, so if we square root 3, this is going to be equal to 3, and this is going to be equal to a squared over b squared. Now we have this b squared denominator here. If we multiply both sides by b squared, we get 3b squared is equal to a squared. So if a squared is equal to 3b squared, this means that a squared is divisible by 3, because it's equal to 3 multiplied by b squared. And if a squared is divisible by 3, this means that a is divisible by 3. The reason for this makes sense if you think about it. The difference between a and a squared is you're multiplying by a. It doesn't matter if it's 3. If a is divisible by any number, so 2, 3, 4, 5, whatever, if you're multiplying a by a to get to a squared, this a squared is still going to be divisible by all these numbers. It's not going to make a difference. So a is also going to be divisible by 3. So if a is divisible by 3, what we can say is that a is equal to 3n, because 3n is also divisible by 3. Say a is equal to 3n, where n is also an integer. And what we can do now is we can sub this in to this equation here. So we've got this 3b squared is equal to a squared, but instead of a, we're going to say that this is 3n. So it's now going to be 3n squared, like this here. We can simplify this. It's going to be 3b squared is equal to, and then 3n squared is going to be 9n squared, like this here. Divide both sides by 3, so we get that b squared is equal to 3n squared. And this is the same logic as before. If b squared is equal to 3n squared, this means that b squared is divisible by 3, and therefore this means that b is divisible by 3. But now we have a contradiction. The contradiction that we have is we said right at the start that a and b are integers and they have no common factors. However, we have proven that a is divisible by 3 and b is divisible by 3. They both have a factor of 3. So we have a contradiction. This contradicts that a and b have no common factors. So therefore we've found our contradiction, so therefore we have contradicted this assumption up here. So therefore we can now say, as a final conclusion, as we found the contradiction, we can say that root 3 is an irrational number. Then that there would give you all 6 marks.